Before we start on the notes on operating with scientific notation with multiplication and division, I want to review with you the commutative property of multiplication. And there's commutative property for multiplication, and there's also commutative property for addition. But if we look at multiplication, if I take 3 times 2 times 4 times 5, and I multiply those together, I get 6 times 20, which is equal to 120. And then I could rearrange those because it doesn't matter what order you multiply them in. If it's all multiplication, you should get the same answer. So I'm going to now write it as 3 times 4 times 2 times 5. So commutative property means you move them around. And so 3 times 4 is 12 times 2 times 5, which is 10. And 12 times 10 is 120. So that shows doesn't matter what order we multiply in. And that's going to be important when we get to scientific notation, since scientific notation is two different factors multiplied together. So if you'll read this problem to yourself, just pause the video and then come back and we'll underline important information. Alright, welcome back. And if you've read the problem, we know that the mass of Pluto, that's important, is about 1.3 times 10 to the 22nd kilograms. And we want to know how many times smaller is Pluto's mass than the Earth's mass. So that's what we're trying to find. And we know that the Earth's mass, underline that, is 5.97 times 10 to the 24th kilograms. So if the Earth's mass is bigger, and we want to know how many times bigger than Pluto, we'll have to divide. So we'll take the Earth's mass, 5.97 times 10 to the 24th, and we will divide it by Pluto's mass, which is 1.3 times 10 to the 22nd. So what we can do, since these are both factors, because there's a time sign between them, we can actually split them up, and I can just divide 5.97 by 1.3, and I can divide 10 to the 24th by 10 to the 22nd, and then I'll have my answer, and then if I need to, I can rearrange it to put it in scientific notation. So we're going to split this up and say 5.97 divided by 1.3, and then times 10 to the 24th divided by 10 to the 22nd. So on our calculator, if I take 5.97 and divide it by 1.3, get 4.592. We're just going to round that to the nearest hundredth. So we're just going to say it's about, because up here it says it's about 4.59. It was a 2 behind it, so we'll just leave it 9. And then times, now we're going to divide 10 to the 24th by 10 to the 22nd. Well, if we have like bases, when we divide, all we have to do is subtract the exponents, and that's what we learned last week when we talked about properties of exponents. So that's going to be 4.59 times 10 to the 2nd power. And they want the answer in scientific notation. So this would be your final answer. And that's how many times smaller. Remember, we had kilograms for the weight of the Earth and kilograms for the weight of Pluto. So those divide out and give us 1. So this is just how many times bigger. It doesn't have a dimension on it. And if you did want to look at what number that would be 459. Because if you move the decimal point over 2 by multiplying it by 100, so it's 459 times bigger. What's 459 times bigger? Earth is 459 times bigger than Pluto. But they want the answer in scientific notation. Okay, so let's look at example number 2 now. So if you'll pause the video and read it, and then we'll come back and underline important information, circle what we're trying to find. Alright, so if we look at the space shuttle orbits the Earth at a speed of approximately 2.8 times 10 to the 4th kilometers per hour. So this is the speed of the space shuttle. And the longest shuttle mission was about 4.2 times 10 to the 2nd hours long. That's the longest mission. And they want us to find the approximate distance that the shuttle traveled during its mission. So that's what we're trying to find right here. And we're going to put our answer in scientific notation. So if this is the speed, and this is how many hours it took, then to find out how many kilometers, we would multiply these two figures together. So if we take 2.8 times 10 to the 4th kilometers per hour, and we multiply that times 4.2 times 10 to the 2nd hours. So this is all multiplication. So we could rearrange this multiplication by the commutative property, and we could put the 2.8 times the 4.2, and I'm going to use parentheses so I don't get all these decimal points and dots mixed up, and then times, and then I'm going to put 10 to the 4th power times 10 to the 2nd power, and then down here I'm going to put kilometers per hour times hours. Alright, so if I multiply these two on my calculator, if I do 2.8 times 4.2, we get 11.76 times 10 to the 4th times 10 to the 2nd. We add the exponents, so that's going to be 10 to the 4 plus 2. And then kilometers per hour over, or times hours over 1, the hours divide out, and I'm left with a label of kilometers. So it's going to be 11.76 times 10 to the 6th kilometers. Now, we have to put it in scientific notation. Well, technically, this is not in standard scientific notation because this number is not between greater than or equal to 1 and less than 10. So we have to move the decimal point back 1 so that it reads 1.176. Well, if I'm going to move it back 1, then instead of moving it 6 places from here, which would be right there, I have to move it 7 places if I'm going to move it back 1 to get the same answer. So that's going to be times 10 to the 7th kilometers. And so that is our final answer right here. 1.76 times 10 to the 7th kilometers. So when you come in tomorrow, I would like for you to put your fist out, and we'll do a fist bump. Don't tell anybody.